Okay, here is the shortened dipole antenna for 80 meters that I built for our NVIS testing. So what it is it's an electrically shortened dipole. And so you'll see on, here's the loading coil here. And this is about 2¼ inches diameter piece of PVC, just a junk piece, obviously with a really rough cut. And I've wrapped around here 28 wraps to give me the coil inductance that I need. And then on one side I have 3 foot 6 inches of wire, and the other side is a little bit less than 20 feet. I'll get an exact measurement and post that. And this is based on a design from the K7MEM, Kilo 7 Mike Echo Mike website. He has a bunch of different antenna designs, and this one is based on his called a short dipole on his antenna first antenna page. And so it's a shortened dipole, electrically shortened. And so the short, very short ends of the wire, the 3 foot 6 ends, are going to go into this terminal post B and C. So one's going to go into the positive, the other one into the negative, or of the antenna. And then they both go out to rope or whatever. And this is, I installed this temporarily at home and had it about 6 feet off the ground at the highest point, and maybe 2.5 or 3 feet at the lowest point. So the highest point was, for me, was this terminal post, and lowest point were the far ends, where it was just 2 or 3 feet off the ground. And the wire I used was this spool of wire that you can get. I got it off Amazon, and this is 300 feet, 20 gauge wire, and I think it was around $30 for 300 feet. And so I've used very little of it to make this antenna. And so this is absolutely a compromised antenna, seeing as so much of the wire for the antenna is in these loading coils. But then again, we don't need a terribly efficient antenna, and we don't need height on this antenna because we're looking for NVIS, near vertical incidence skywave. So we're planning to send pretty much all of the RF straight up and have it reflect back down off the ionosphere into our region for local and regional communications. So this is it. This is what I built, and what I did is I apparently didn't have a saw that was very sharp, but I cut these tubes, and then I drilled a couple holes. You can see, I'll show you on this side, a couple holes there. So I fed the wire through a couple times, go in the hole and back out, and it kind of acts as a strain relief there, and wrapped the 28 wraps, and then did the same thing on the other end. And then I just put electrical tape over it. Now this is not considered a permanent antenna setup. It kind of reflects on how I built it. This wouldn't last long term outdoors, but then also at 4 to 6 feet off the ground, it's not really going to be an ideal antenna to keep up in the backyard anyway, if you plan on having anyone in the backyard, or even deer or dogs. So this is just meant to be put up for a few hours or a few days and used, taken back down. It's very portable. It all fits in one of these Ziploc bags, and it works well. This is I was running this at 100 watts, and there wasn't any issue. Now 1-to-1 balun would be a good idea to keep any stray RF off of the coax. You can do just a simple several loops of coax close to this feed point, and that can act as a choke, as an RF choke. Or you can actually add a 1-to-1 balun on there. But I'll go ahead and cut, and then I'll put this antenna up, and I'll show you it, actually in the air, a few feet in the air. And then I'll show you the results that I'm getting off of that. And I'll also include the measurements for these longer sections of wire. Okay, the antenna is up. And as you can see, it's only 2.5 feet off the ground at the feed point right there. You can see that. And on the positive end of the dipole, at the top, at the highest point, it probably goes up to 6.5 feet. right up by that aluminum pole there. And then the other end still stays around 3 feet over to that chair. And so this is the whole antenna, and it is not high up. It's very low to the ground, and I have quite a bit of coax to get out to this point. Hopefully you can hear me with the wind here. But this is it. This is the whole NVIS antenna. As you can see, I can string it to whatever, a branch. It doesn't matter, a chair, a stick, and it works. So I'll show you inside where the resonance is. All right, please forgive the clutter here, but the antenna is up, and I'm going to show you it's resonant a little lower than it was the last time I installed it, but I put it in a different part of the yard. So let me give you a little example. This is SWR. I'm running no tuner on the radio, and also I'm running through this tuner, but just direct without going through any of the actual tuner itself. And so you can see I'm in AM. SWR is very low. N0ZIB testing. Now if I go all the way down to the bottom of the band, well, if I go further down, way high. And if I go up towards the top, well, I don't want to go out of band. Again, way high. So this is a very high Q antenna. So what that means is that its resonance point, as you start to stray from it, the SWR goes up quickly. So it's resonant, but only in a very specific area. And that's due to partly because we're so close to the ground. There's a lot of ground interaction, but then primarily because of those loading coils. And so we have a lot of inductance going on there. And that's one of the reasons why this is such a high Q antenna, which it can still be fine. It just requires a little tuning, and if you know where you're going to put it up, tune it for that specific area, and you should be in good shape. It looks like my internal tuner can probably handle the whole band, just about the whole band. Let's see. Yeah, it doesn't really like it right there. But let's go down a little bit. Okay, well, apparently I'm a liar. There we go. So it'll tune there, and then I would imagine it's going to tune the bottom of the band also, because the reflected power wasn't quite so high over there. But that's it. It's working, and I'll show you the graph on the Nano VNA. All right, here's a graph on the Nano VNA of this NVIS antenna, and you can see the big dip here. That is at about 3.85 megahertz. That is the resonant point. Right in there is 1.21 to 1 SWR. And you can see how it climbs on either side of that point. It climbs quite a bit. And let me also scroll out here, or zoom out, I guess. Let's stop it at 15 megahertz. See, it has some other resonance or areas where it's a little better than others, but you can see the actual point where it, the primary point on this antenna, the resonance point is 3.85, which is what we want. And so that's antennas functioning as we intended. So now that the project is finished and I've tried it out and it works, there are a couple things I would probably do differently, like the core material for this 2 and I think it's 2 3/8 outside diameter PVC. I would try to go with something thinner. This is not all that thick, but it does seem to weigh down the wire quite a bit and put some extra stress on this 20 gauge wire. So there's that. I would probably build one a little bit longer. I think this is somewhere around 42 feet. 42, 43 feet overall, and that is pretty compromised, a pretty compromised antenna design. So I think I would probably increase the length of the antenna. If I could go to 60 feet overall, I think that'd be a big improvement, and still keeping it low and temporary would be nice. We're going to try it out. A couple club members and I are going to be getting on the air later this afternoon and trying out some NVIS com. So we'll see. I'll put this antenna back up and see how it goes. I don't know. Otherwise, I'm pretty happy with it. Let's see, the design on W7MEM design calculator, where you can enter the frequency that you'd like the antenna to be resonant, and then how much space you have available, overall space for the antenna, and it'll give you a couple different options for builds. And so this one, if I calculate for this antenna, I calculated I had 44 feet available, and that also I wanted to be resonant around 3.9 megahertz. And it came up with this design of, from the center BNC terminal post going 3'6" out each way, to the loading coils that were going to be 39 microhenry, and then out another, well, the way I measured it was different, but about another 18 feet each way to the end insulators. And so to calculate how I would need to make this coil, I had to go find an air coil calculator, an air coil inductor calculator online, and there were several to choose from, but I'll throw up on the screen what I ended up using, and it worked pretty well. You can type in the diameter of this coil material, the base material that you're using, and so 2.375, so 2 3/8, and then how long the coil length in inches, which I guess you don't really know until you do it. But I typed in 2 inches and I got number of turns. I kind of was guessing around until I came up with about 18.5, and I come up with an inductance, an estimated inductance of 37.3 microhenry, which is pretty close to the 39 that's necessary in this design. And then also, this design is not intended as an NVIS antenna, so that changes some things also. And so with this design, I got like you saw, the resonance at 3.85 megahertz, and that's with an inductor closer to 37 microhenry, and the ends were a little bit shorter. They were about 17 foot 8 inches on each end. And so I think a lot of that probably has to do with the NVIS setup that I used. In the installation today that you saw, I was even lower to the ground than I was the last time I tested this antenna, and it actually affected the resonance by quite a bit. I wasn't at 3.9 anymore. I was at 3.85, and that was with no adjustment to the antenna length. That was just height from the ground. So it does play quite a bit of a difference, along with anything. Ground conductivity plays a difference too. I built a second one of these antennas for a friend, and his tuning has been quite a bit different than what I've experienced with this one. So ground conductivity can be play a big factor, as well as any structures around, because there's interaction and coupling that happen with any bigger structures. I'd imagine bigger trees can be more of an issue, along with anything that's metal or conductive nearby. So that's it. Thanks for sticking with me this long, and hopefully you're able to build this, and it's definitely a fun little project.